Often we get the question, what is the impact of the Tanium agent on the endpoint? Well, today we're going to unpack that answer. Welcome back to Tanium Tech Talks. I'm your host, Ashley McGlone. Glad you're here because today we are starting a new series. And I wish I had a dollar for every time I've heard the question, what is the impact of the Tanium agent on the endpoint? Because any sysadmin worth their salt is going to ask that question. So we want to talk about that. Also, how do we tune that for performance in our environment? Talk about proper antivirus exceptions and what should I consider if I've got virtual infrastructure and things like that. Today though, we're going to focus on the baseline of just what is the load of the Tanium agent on my endpoints. Well, joining me on the show today is an industry veteran, my friend and colleague, Jeff Stokes. Jeff and I go way back to our days at Microsoft, and he's a legend in his own right. And somehow, I'm not sure how this has happened, but after 3 years of doing this show, is just now his first time of coming on Tanium Tech Talk. So help me welcome Jeff to the show. Jeff, please introduce yourself for our viewers.
My name is Jeff Stokes. I've been in IT, I think 29 or 30 years now, and I've been at Tanium about seven. I think it'll be seven in May. Yeah, and I'm a principal escalation engineer here at Tanium.
So, Jeff, I really would like our viewers to understand what does that job title mean today that you've got principal escalation engineer? What do you, because you get to do some really cool things. What do you do in that role?
Yeah, I've had a fun track record here at Tanium, but yeah, the principal escalation engineer. I'm working with our customers, endpoint or backend or virtualization performance or network or what have you, and basically it's stop the bleeding, restore service, and find out what went wrong. If it's something that we need to do better, roll that back into our product, or make sure that the engineers that did the thing understand what happened and whatnot. Sometimes root cause is written up, things like that too. Yeah.
And now we've got a whole team of principal escalation engineers as you're one of a team and people with equal credibility in the
Mhm.
industry for the experience that they've got. So it's great that we get to do this here today together. So, I was thinking about this. Maybe a good place to start is just kind of state of the endpoint. Since you've got this unique view of the industry and these conversations you have with customers, you probably see a lot of different agents installed. And I know when we talk to people about Tanium, part of our marketing is that, hey, look, you've got all these agents. Why don't you consolidate them and save some headroom on your endpoint by consolidating the workload by eliminating some of those other agents? But I'm curious to hear from you. What are you seeing today as kind of the standard baseline for how many agents are people running on their endpoint, and what are their use cases for those?
It varies. I think back to our Microsoft days where we referred to customers as being on an IT journey, and it really depends on, I think, where they're at in that journey on how many agents they end up running. Was working a case pretty recently where I think they had three different compliance based scanners. They had at least four different agents that all collected performance metrics. And when I pressed, just mainly curiosity more than anything, but also it's an impact, right? There's a cost of everything when you do something on an endpoint. Who's looking at this data, and do they know it's being collected elsewhere? Really the same metrics in a lot of cases. And a lot of times there's just that sort of ITIL siloing. We don't know, is the answer you get back, where you've got all these different groups that each need an agent to collect the data into the system that they use for monitoring and uptime and reliability or capacity planning or what have you. I think there's not a lot of discussion about that, sort of what are we collecting? Does it make sense for us to share this versus install another agent? In that customer's case, I think they had like nine or 10 agents on the endpoint, including us. It's an interesting mix of performance and reliability scenarios and things like that. I know we wanted to talk about exclusions a little bit, and that kind of brings up the are your tools smart enough to not monitor each other, or do they need to monitor each other? I don't know. It's really it's a business decision. Do we need to monitor the monitor? And then what's the cost associated with that? I think is something that a lot of times isn't really calculated into the equation on when purchases are made and things like that. So it's pretty interesting to see the mix that you get. And of course, we're going down market, and we have enterprise customers and PubSec and everything else. So really runs the gambit of endpoints across the world, across the ecosystem.
Like you said, we're a global company. We have some of the
Mhm.
largest companies in the world, some of the smallest companies in the world,
Yeah,
and everything in between. So you're going to see every kind of footprint on the agents there. And usually there's different teams that own those agents. And I'm glad you pointed that out because that's really the fundamental question that we don't think about is why is that agent there to begin with? Who
right,
needs the data? Do we really need to be collecting this? And so that's maybe a good place to start is do you even need the agent? And that's where Tanium comes in, is because we can consolidate a lot of those to a single footprint with a governor or a cap on that agent so it's not going to run away. If you have 10 agents all taking up the machine, with their own throttles, then you've got accumulated 10 throttles. But if you've got one agent that's got a throttle, then you've brought that down, right?
right, right.
So why don't we start with just the baseline question today? Everybody wants to know what can I expect for the agent endpoint impact from Tanium?
So when we look at I'm obviously my background's mainly Windows, so I'll address it from that perspective first. I think uh, when you run every last bit of content that we have, in terms of modules turned up and everything else, we can use up to, I think it's about 800 megabytes of memory on occasion. One of the interesting things with Windows, and it's been designed this way for some time, one of the interesting things with it is that when you have memory that's consumed, the memory manager in Windows is going to keep an eye on that. And as memory pressure happens, or if it does happen, it's going to start going in and looking at each one of those processes that has a lot of memory. And it's like, well, I know that you have like this gig of RAM in here in your process, but you haven't touched like half of it in forever. So I'm just going to put that in the page file, and you can think it's in memory. And so you have those type of shenanigans going on all the time in the background, right? So if you have an endpoint that literally is doing nothing else but running Tanium, you could expect to see it maybe 800 megabytes or whatever. But now if you're going to fire up Office, you're going to see our memory footprint go down as Windows Memory Manager is going to go in and trim. And then 800 is not a fixed number. That's a variation of, different modules doing things at different times. Are we patching, or are we doing a compliance scan, what have you? Think about the endpoint as sort of this chaotic system, where you've got all these competing processes all wanting to have access to the same, in some cases, scarce resources like CPU time or memory, or I need network bandwidth, or I need disk throughput. And Windows, I think over the years has gotten to a pretty good place where it does a good job of sort of balancing those out, the needs between all the different processes, as they compete for these resources. And then, I know we're going to talk about virtualization at some point. Of course, that brings in a whole other thing. It's like, how do we configure the endpoint? Is it a physical endpoint with 20 cores and it's 64 gig of RAM and an SSD, or is it some laptop that, probably should be given to like a family member you don't like, you know?
That's a polite way to put it.
Sure.
Like if somebody went out and bought all the Tanium modules, loaded everything up, so you're saying it would kind of spike to 800 megs of memory. Because I'm thinking a lot of customers might just have, 3 or 4 or 5 modules. And again, it depends, right? The engineering answer always here is it always depends, right? So
Well, yeah,
what
yeah.
would you say is kind of an average that you see?
I would say it's probably about half that. Yeah. In terms of the actual memory consumed. Now, virtual memory, of course, is going to be all over the place, right? As different processes will request memory, but not necessarily actually ever allocate it, use it. They just put in a request. It's interesting. We've been talking a lot about memory lately. James Klepicow, another principal escalation engineer here, and I, and some of our EEs and whatnot, that we run into customers that don't run a page file at all. Um, I don't know where this kind of guidance is coming from, but it puts the operating system in kind of this unique position where it can't do the memory shell game that the Windows Memory Manager is actually made to do really well. That what is happening is instead of being able to go in and trim things off and put it in the page file, things are just left to their own devices pretty much. We've seen some interesting scenarios where like patch wants to patch the endpoint. Okay, well, that's going to take some memory. Okay, well, it's also running SQL. Okay, well, that's going to take some memory too. And as you know, SQL can pin, right? So
Hmm.
now it's like, well, where is this memory going to come from? And are we going to run out of memory? And I don't think that people that are setting to an endpoint to have no page file really have thought through what's the implication of doing that. And on the internet, you find all kinds of weird guidance over the years. Page file needs to be 2 times the size of RAM plus a whatever, or there's all these calculations and everything. Microsoft has a really good article on how to actually properly tune a machine and understand the footprint, but the real answer is just let it kind of system manage on its own. It does a pretty good job doing that these days. We run into these things where it's like, page file set, it's a 2 core box, it's got 4 gig of RAM. It's like, let's run out of memory. It's like, well, yeah, it's working as designed, but that becomes an educational call of, well,
Hmm.
here's what's happening, right? In layman's terms, what's actually happening on this endpoint, and then how do we sort of fix that, and either through configuration change, adding resources, whatever the solution may be, but opportunity to show something more about how the operating system works, and how things are sort of allocated and deallocated and whatnot, and as the day goes on.
So that's the memory footprint. What about CPU? I know if I understand it correctly, CPU is the one thing we actually throttle. Is that
We
right? We
do.
don't. So
Yeah.
that's we don't throttle memory necessarily, but we do throttle CPU, right?
Right. Yeah. So in CPU land, what we look at is it's, I believe, 25% of a core on the endpoint, and that's a core. So now, but then different throttles and different mechanisms are in there for each module to help govern the CPU load that we put on an endpoint. And some of those are based on how many CPUs are there. Like, for example, if you have a compliance scan, does it make sense to throttle a compliance scan to use a quarter of a core? I don't know. Probably not, particularly if it's going to take a while. Or patching or looking for a vulnerability. So it's an interesting sort of calculus, if you will, that when we instantiate a throttle or a limit or a cap, on CPU resources, what does that actually mean? Does that mean that we get our answer on whether or not we're popped later because we weren't able to look at our endpoints? So it's almost a, where is the business need of having information now, which is what we really pride ourselves on, right? Is getting your information, quickly in your environment, and being able to pivot and act on it. And if you start throttling and governing everything, where does that end up in terms of what your SLA is expecting, or what the business need is? It's a pretty interesting discussion. And it goes back to that age old engineering, it depends, of course. And then every environment, is different as well. Everyone's running their own types of software. Everyone's got different types of hardware, different configurations were used, different build processes. Different engineers support it and have their own tips, tricks that they've done over the years. It's really interesting. That's one of the things that kind of attracts me to the Windows ecosystem in general. Is just that variety. Helps with my ADHD, I guess. Anyway,
Yeah.
yeah,
So we're approximately a quarter of a core. So if you have a typical laptop with a quad core processor, we really shouldn't be making a dent on the CPU then.
and Task Manager, of course, is going to aggregate it all into a single CPU view. And as you know, I've railed over the years about Task Manager being wildly inaccurate here and there, but Yeah, it'll lump it in. So really, you shouldn't see Tanium using above. I think it's like
Yeah,
16.
16th. Yeah.
Yeah, yeah,
So we talked about memory and CPU, and disk is always interesting because a lot of people think about capacity, like depending on what modules, how much disk space do I need to allocate for file management? But
right.
really, I think the bigger question really as far as performance is like the IO to the
Yeah,
disk, right?
yeah. It's when a while back I did a lab to basically come up with the VDI guidance for Windows 7 and 8. And when I was over at Microsoft and we were talking about it, and the IO load of just Windows, I think is like, you want to count on like 100 IOPS at the time. So at any given time, there's 100 IOs going on, per second on this endpoint. And then what's the sort of capacity, because this is back when spinners existed, so it's like, well, how big of a disk queue do you really want? And then each agent, each piece of software on the endpoint, every user action is potentially going to impact that disk queue. And yeah, you're absolutely right that disk size is of course a metric to keep track of because you don't want to run out of the space. But the disk IO throughput is a much more important resource to be monitoring. Absolutely, we've made a lot of improvements over the years, going over disk usage using the Windows memory cache, and we're working on things. It's like, is it an SSD? Is it an NVMe? What's actually the capacity able to do? It's an interesting question of how much resources is it okay to use, and again, it's going to depend on the hardware. Bruce Worthington a long time ago wrote an article about the perceived or the advertised performance metrics, and then what's the real world under the hood of like a PCI bus and a SATA drive and a SCSI drive and things like that. Pretty interesting that you see the advertised throughput will be like, oh, it'll do six gig a second, or whatever, 600 megabits a second, and then you go in and look at it, it's like, well, it's doing like a tenth of it, and it's sweating. So yeah, it's pretty interesting to take a look at that. And a lot of it comes down to endpoint cost. Are we spending the money we need to on the endpoints to make them performant for the workload we're really expecting our users to have to do? And just the agent impact as well. I think a lot of times there's a sort of a compromise on the endpoint. I did a talk about this a while back where customers will or enterprises will go in and spend money on high speed routers and SANs and this and that and cloud, and but then the endpoints they end up getting for the users are like $500 or less machines, just commodity hardware, spinning disks, low memory, slow CPUs. There's a technical cost to that, but what's the morale cost? I ended up I did an engagement once where the union was doing an exploratory thing for a lawsuit against this company, because the company said when you get into the office you need to be working, and that's what we pay you for, is when you start working, when you log in, when you start typing and doing your work. And they said, well, it should be when we enter the building, because your boot up and log on times aren't our problem.
Yeah, classic debates on boot up times. Yeah.
Yeah, right. And
Yeah.
this is a while back, and yeah, but you look
Uh-huh.
at that and it's like, well, yeah, they have a point, but
Hmm.
did cross your mind, how long is this thing going to take to actually be usable for my user? And is it going to stay usable? When we put
Hmm.
antivirus and IDS and then, all these agents and compliance checks and, threat response or patching or what have you. I mean, obviously you don't need everyone to have a thoroughbred, but you don't want to give your people that need to get work done mules either. I
Hmm.
mean, it's got its place, I guess. Yeah, I think the end users, in fact, I really think BYOD was kind of a rebellion against the cheap endpoint at enterprises, where it's like,
Hmm.
yeah, you think about it, you have this user that would rather go spend their own money at Best Buy or wherever, buying hardware, Amazon, wherever they're going to get it. They're willing to fork over that money to have a performing endpoint for their job. And it's like, geez, yeah, that really says a lot in a way, you know.
Yeah. So Jeff, I know when we were at Converge, Platform 7.6 was a big announcement, a lot of enhancements there around just the ridiculous speed of question response. And a lot of that has to do with the question going to the endpoint agent, getting the response, and disk and memory and CPU are impacted there.
Mhm.
What are some of the disk, and as we're talking about disk here, what are some of the disk enhancements in 7.6?
Yeah, for 7.6, we don't want to get into the weeds too much in this format, but you look at the changes we did in 7.6 to, strings and, handling the metadata for Tanium queries and things like that. We sort of I think 7.6 was like a 1 or 2 year undertaking where it was like a re-envisioning of the Tanium agent on endpoints. And I've had many customers I mean, at least 4 or 5 comment, wow, since we got to 7.6, this thing is just super fast. Takes me back to when I first interviewed, or actually before the interview, when someone showed me the Tanium agent and they could type something in and they, in 10 or 15 seconds, they get an answer back. And it's like, that's real data. That's not from a database. And back then I was like, no way. Because, I would assume that either it's in the database or it would take eons to get. And yeah, with 7.6, it's kind of like that moment all over again, in terms of the speed increase. But yeah, to get into the details, we basically looked at the disk footprint utilization that we had from 7.4 and previous versions, and said, where does it make sense to utilize memory here? Which then that comes into, okay, well, now we're not doing disk IO, we're not storing the files on disk potentially, we're in memory. So now does the memory footprint get bigger because you went to 7.6? Maybe. But again, if you're trusting the Windows Memory Manager and you have a page file set and everything, it really shouldn't matter. It was sort of a re-rationalization of disk throughput. Also CPU consumption. The 7.6 agent was a pretty big leap forward for us, I think.
So there's four categories of endpoint performance, right? Memory,
Yeah,
CPU, disk, and then network. We haven't talked about
network.
that very much because I know over the years I've heard people ask, well, exactly what's this going to do to network traffic for my endpoint, for my network as a whole? What have you seen?
For what you're getting, it's pretty lightweight, I think. What we've been seeing is that, and this is sort of counterintuitive, I think. We've had some environments where they have turned off network neighborhood and done direct connections to the zone server or the back end, not to reduce the network activity, but to reduce the IO generated in a backplane in a hypervisor, right? Which we'll get into that in another show. There are scenarios where the network IO in itself is not actually an issue. It's the IO that's generated on the Windows side as it processes that and then spits it back out. All that computation has to go back and forth between a network card and a CPU and memory, right? So as that's happening in some environments, they've been resource constrained on their backplanes and not really realizing it. And so when they upgrade, they end up coming in and saying, "Wait a minute, um, we're doing too much I/O." And it's, well, what kind? And it's what's the backplane on the chassis, right? Which, like, how do you monitor that, right? It's a bit of a bear. We've got some scenarios where that's actually a valid step, is to turn off the network neighborhood and actually do direct connection. Starting in Windows, I think it was 10 or 11, they let you do a widget now where you can see your top talking apps on the network. Like my gaming machines like Steam and Discord and stuff like that. Yeah, enterprises have come to us saying, "Hey, is this normal? To see this amount of traffic on our network on a per endpoint basis?" Yeah, I mean it is. You are using the network in a way that you're probably not used to, but overall, the throughput shouldn't be something that impacts networking equipment or anything like that. If there is, then we need to know about it so we can figure out what's going on. But yeah, it should be pretty lightweight in my opinion. I don't have an exact number because again, it depends. Like how many endpoints are in the neighborhood, how many, and then are we going to count all the other traffic? broadcasts and ARP, and there's a lot going on, obviously, in enterprise configuration.
Yeah, one time I had a
Yeah,
banking customer who had um, m- bank branches that had a fraction of a T1,
yeah,
and we were able to throttle down from the server side, and they were able to do patching and software delivery, and then
mhm,
and it was still working. Even with a fraction of what would be considered normal bandwidth today. So a fraction of a fraction of what would be normal today.
right.
So it is pretty lightweight on the
It
network,
is, yeah.
honestly. Yeah.
And of course, when you have those scenarios like oil rigs or ships at sea, or like a cruise liner, or what have you, there's all these different scenarios where you have to think about bandwidth constraints, not necessarily on the local endpoint, but how do you get there and back? It's interesting, but yeah, we have the ability to do subnet based throttling. We've had that for some time, so yeah, that's a definitely a good knob to use in a situation like that for sure. Yeah.
Well, that's a good segue into my next question. So, memory, CPU, disk network. As a Tanium admin watching this show, I'm thinking, okay, is there a knob I can turn to make this better or worse? But you've already talked about Windows memory management is kind of doing a pretty good job. Does the Tanium platform kind of manage its own performance, or are there knobs that everyday Tanium admins should consider, or is it better just to keep your hands off?
Yeah, so there are a few. You can we have some modules that have like a low resource mode, for smaller endpoints. We've had to use that some for like thin clients, right? Is a really good use case example, where they're running like a Windows or a Linux based thin client, and we want to run the agent on it to make sure it's secure. I mean, people used to take thin clients for granted until Bash vulnerability came out, right? It's like, Bash is on every Linux install I've ever heard of. Although there's probably one that it's not. That vulnerability, I think, opened people's eyes. Like, well, how do you patch the thin client? I remember it used to be back when I was doing a lot of VDI work at Microsoft that no one cared about the thin client. Oh, if it just breaks, you throw it away. Who cares? It's like, well, yeah, but what about the security of it? Oh, yeah. But yeah, we do have some low resource knobs, and then also in virtualized environments in particular, we have the distribute over time, which I think some admins don't think about. It's labeled the VDI content by us, but it's really anything that's using a shared infrastructure. Of course, shared infrastructure content doesn't really have the same kind of ring to it. Anything that's doing like a shared SAN fabric, or shared disks in the back end, or whatever. And yeah, distribute over time probably makes a lot of sense in those scenarios.
Yeah, I think what we'll do is we'll put a pin in that whole virtual topic because I want to come back and do it just a whole show
Yeah,
on because we do have a lot to help with the VDI and VMs. I'm curious. We've talked a lot about Windows. What about
yeah.
performance on Mac and Linux endpoints?
Well, Macs just work, that, so everything's fine with those. No, yeah. So Linux, the only real gotcha that I think that hits people with Linux is that Audit D can be pretty noisy, and real busy on CPU time. And we've had some scenarios where Audit D was auditing Tanium, causing a lot of resource contention on the endpoint. Or we've seen it where, actually, I think that's the main thing, is the Audit D. I think it's eBPF is what they're supposed to be going to. Linux, in some ways, I think we're actually a little thinner on the endpoint on a Linux endpoint than we are on a Windows one. And then one of the things we're doing is looking at module reduction. Where does it make sense for us to be shipping or loading modules when they already reside in memory somewhere else? And I think with Linux in particular, it'll make us thin out our agent a bit more. But I know that's something we've been working on, is consolidated process mode, right? Where instead of the Tanium agent having a process per module content or script action or sensor or what have you, that opens up and then goes away, we just run it as a unified process. And there's some savings to be had in there, where if someone already has that module loaded. Why are we loading it again? And really, that should, that I think as people move to that shared process mode, that they'll see a kind of a reduced impact in terms of memory on the endpoint. Yeah.
That's a good little nugget to pin for another episode as well. We do plan to talk about shared process mode a little bit later on another
Yeah.
episode. And just to, we're out of time, unfortunately. I'd
Oh,
love to keep. We're gonna make more of these episodes in this series, but just to put a quick a note out there, where can I see performance from the Tanium console if I'm concerned about performance of endpoints across the enterprise? Where can I go find that?
if you have the performance module, that's a no-brainer, right? Go into the performance module. You can do a direct connect, see what's going on in your endpoint, or you can do the enterprise scale questions of, who has how many app crashes, whatever. What chassis is the lemon in my fleet is always a good one to find out. If you don't have that, TCM, Tanium Client Management, go into client health, take a look at it there. And then, of course, on the endpoint, we have content to collect the depth traces that I, and others here read to, understand what the performance of the endpoint actually is from the kernel perspective.
Yeah, so we've got a link for you in the show notes below
Yeah.
for a Tanium community article out at the Tanium Resource Center. If you go to help.tanium.com and just type in ETL, there in the first hit in the search results, you'll see an article called Producing Microsoft Windows ETLs for Improved Endpoint Analysis with Tanium's Default Content. Tell us a little bit about what is an ETL, Jeff, and how does that help you in your role?
I think I've been reading these now since like 2009, ETL traces. So it's event trace log, and the processing part of Windows that sort of generates those is the event tracing for Windows subsystem. And most of the event logs now, or I think probably all of them, are ETL based or ETW based, where they stream in data. ETW is made, for the Windows kernel to be very lightweight and performant as it records tens of thousands or more events per second. It's actually been around, I think, since Windows 2000 Server in some fashion. I think that's what Yang Ri, shout out to Yang, had told me at one point, is that WMI content or something way back in 2000, you could actually do ETW. If you as an admin have used Process Explorer, Process Monitor, those are ETW consumers where they're going in and reading what's going on. At least I believe that's the case. These tools, basically connect to the subsystem, and you can get a very good granular view of what's happening in terms of the CPU usage, memory, who's opening handles, what's happening on the disk, the network activity. NetSH tracing is ETW based, right? And that'll collect a trace file that you can convert into Wireshark, and then you don't have to install anything to collect a network trace. It's been around for a while. It's pretty robust. Got a number of folks here that can read those traces pretty well. So we kind of use that as the gold standard, particularly for high CPU, CPU consumption events. I think that's kind of a gold standard as, the ETL traces that we look at. Yeah.
So,
No
Jeff,
problem.
thanks for this tour of Tanium Agent performance today. And anything else as we wrap up?
I think that if anything, I want to leave as far as a message for folks is that if things aren't performing well, then we want to know about it. We want to know why and what the expectation is, so that we can improve our agent.
Well, Jeff, thank you so much for joining us today on the show and helping us understand the Tanium agent performance on endpoints, whether it's Windows, Mac, or Linux, or servers or workstations, and in so many different environments. It's really complex with so many other agents that have to all play well together, and that's part of your job is teasing that out. So thank you for this glimpse into what Tanium Principal Escalation Engineer means and what you guys do on a daily basis. Thank you for your help to us and our customers.
Thanks for having me.
And for those of you watching, check out that community post below there for on how to collect ETL traces that you can then use Tanium to collect those to provide them to our support engineers
Mhm.
as you're working through tickets. So thank you for joining today's Tanium Tech Talk, and stay tuned for more in this series on the Tanium Agent Performance FAQs. Until next time, go Tanium.